This next problem is a little bit different than the last one. Here we're talking about processing gold from gold ore, and we have two different sources that can process it. So from source A, it's $20 per ton to process the gold, and from source B, it's $10 to process. And our cost must be kept to no more than $80 per day. So that sounds like these three parts will go together. Let's keep reading. Now, each source has a limited number of hours to process each day. That makes sense. The factory can only run for so long. Source A can operate for 6 hours a day, and B can operate for 12 hours a day. And the total hours must be kept to 60 hours. So we see we have hours, hours, and hours. Looks like those three will go together. Now, if gold from source A yields 2 ounces of gold per ton, and source B is 3 ounces per ton, our question is how many tons of ore must be produced each day to maximize the output. So we want to maximize our output of gold. We want to have the most amount of gold that we possibly can. Well, let's start with some constraints. And remember we talked about the cost at first. So if we have $20 for source A, and we have $10 for source B, and we have to keep it under, or at most, $80 per day, so it could be equal to $80 or it could be less than $80. That would be our first constraint. Our second one, we're talking about the hours a day. So we have 6 hours per day for source A, so 6 times A, plus 12 hours for source B, and it says at most 60 hours. And let's recap these real quick. We have cost, and we have cost. So cost for A, cost for B gives me the total cost. Time from A plus the time from B gives me the total amount of time. Okay, and let's see here. The next part talks about 2 ounces of gold per ton and 3 ounces of gold per ton for the two different sources, and we want to maximize the output. So that's talking about the output there, the output of gold, and maximizing the output. That sounds like our objective function. So let's write down our objective function over here. So our output, we could put output equals, now from source A it's 2 ounces, so 2A, and from source B it's 3 ounces, so 3B. And that would be my output. And I want to maximize the amount of output. Now I need a couple more constraints here, because remember in the last one we didn't have anything about like how much you'd have to have of A and how much you'd have to have of B individually. Well, we just got to remember that we're not going to be able to go negative, so if there's nothing else mentioned like you have to produce at least 2 ounces or 3 ounces from A, we can just have A is greater than or equal to 0 and B is greater than or equal to 0. So those two, we just have to make sure that they're positive or equal to 0. Okay, we can't have a negative amount produced at a certain plant. That wouldn't make any sense. Let's go ahead and graph these. Once again, I can use cover-up method. So if I cover up the 10B, which is kind of like 10Y, okay, so your B is kind of like your Y, your A is like your X. If I cover this up, I get A equals 4, and if I cover this one up, I get B equals 8. So let's plot those. So there's my first line, and it's less than or equal to, so I'm going to be shading below the line, which would be on this side of the line. This is below the line, so I'll draw a couple little arrows here instead of shading and making a big mess. Boom, just like that. Let's graph the red one. Once again, if I do the cover-up method here, cover this guy up, I have 6A equals 60, so I get 10 for my A, which is my X, and if I cover this one up, 60 divided by 12 gives me 5, so I get 5 for B, which is my Y. So there's my second line, and once again we're less than, so we're going below the line, so I'll draw a couple arrows there. Below the line, that's where I'm shading. So I can see right now I'm shading in this area, and that is going to be the case after I draw on these two blue guys. So for A is greater than or equal to 0, that's a vertical line. It's like X. It's kind of like think about X equals 0, and it's greater than, so I'm shading on this side. And then for B, it's a horizontal line. So I'm shading above because it's greater than, so like that. So yeah, I am right in here, once again in this little quadrilateral, and I've got 3 points. I've got this guy right here, which is 0, 0. So let's write that down. 0, 0 is one of them. I have this one up here, which looks to be 0, 5. I have this corner point right here, which nicely intersects there at 2, 4. And lastly, this one here, which intersects at 4, 0. So those are my 4 different corner points. Now, how do I figure out how I'm going to get the maximum output? Well, I could use my objective function here by plugging in these corner points from here and then writing down my values for the objective function. Well, if I plug in 0, 0, I'm going to get 0. If I don't do any work, I'm not going to get any money. That's economics 101, I think. I don't know. All right, if I plug in 0, 5, so if I plug in 0 for A and 5 for B, well, that's 0, and then we have 3 times 5 is 15. So it'll be 15 ounces of gold. Then if I have 2, 4, if I plug in 2 for A, that is 4. If I plug in 4 for B, that's 12. That gives me 16. Ooh, there's the highest one so far. Let's see. If I plug in 4, 0, I'm going to get 8 plus 0 gives me 8. So it looks like my maximum output will be 2 from source A and 4 from source B. So let's recap. We use the information in this problem here to set up our constraints, these inequalities down here. We look at our question here. Okay, well, how much can be produced each day to maximize the output? So our output's our objective. We want to maximize our output. That's our objective. So we wrote our objective function there. When we graph the constraints, we look for our corner points. Most of the time there's 4. Sometimes there's 5. Sometimes there's 3. It just depends. But most of the ones that we've dealt with so far have had 4 corner points. We plug those corner points into our objective function to figure out our maximum profit or output in this case. And there you have it.